Let's take a look at this halfway rectifier. This time we're supposed to find average voltage across the load, peak current across the load, average current, output frequency, and PIV. First, I'm going to convert my primary voltage to voltage peak. Voltage RMS is equal voltage peak times 0.707. This is the general formula for RMS voltage. I'm looking for voltage peak. Why I'm looking for voltage peak? Because my problem is going to be much easier, in my personal opinion, to solve if I'm going to convert everything to peak. What I'm going to do first, I'm going to divide this formula by 0.707 on both sides. 0.7 and 0.7 will cancel out, and I'm going to have voltage peak is equal VRMS over 0.707, where my primary voltage RMS is equal 120 volts. That's why I'm going to say V1 peak, primary voltage peak, is equal V1 RMS over 0.707, which is equal 120 volts over 0.707, which is equal 169.73 volts. This is my primary voltage peak. This is this voltage, but I have transformer. I have to check what is my secondary voltage, because I have to find voltage across the load. So if I want to find the secondary voltage, I have to use the formula for transformer, which says V2 over V1, which is equal N2 over N1. In other words, V secondary over V primary is equal secondary winding over the primary winding. I'm looking for V secondary. So in order to solve this proportion, I have to cross multiply. And I'm going to have V2 N1 is equal V1 N2. I'm looking for secondary voltage. In order to find V2, I have to divide both sides equation by N1. N1 and N1 will cancel out, and I'm going to have V2 equals V1 N2 over N1. But because I'm looking for peak voltage, I'm going to write V secondary peak is equal V primary peak times secondary winding over the primary winding. This is my P. So we found the peak primary voltage, which is equal 169.73 volts. I have 169.73 volts over N1, which is equal 8, and I have to multiply everything by 1 because I have V primary times N2. Remember, this is your N1 and this is your N2. This is going to be equal 21.21 volts. This is my secondary voltage, means voltage between these two wires. This is my secondary voltage. The problem is asking me to find average voltage. In order to find the average voltage, I have to find VL peak first. I have to find the peak voltage across the resistor. VL peak is equal V secondary peak minus the voltage drop across the diode. This time we are using silicon diode, and silicon diode has the voltage drop approximately 0.7 volts. That's why in order to find VL peak, I have to subtract from the V secondary peak 0.7 volts. This is nothing else, just the voltage across the diode. And this is going to be equal 21.21 volts minus 0.7 volts is equal 20.51 volts. This is my voltage across the load. This is VL peak. In order to find VL average, you have to remember the formula for half-wave rectifier. VL average, this is equivalent to VL DC, this is also called the DC voltage, is equal VL peak times 0.318. Remember, this is the constant. VL peak is equal 20.51 volts times 0.318, which is equal 6.52 volts. This is my DC voltage across the resistor RL. Next, I'm supposed to find IL peak. IL peak, I'm going to find by using Ohm's law. Ohm's law says current is equal voltage over resistance. So if I want to find the current which goes through RL, I simply divide VL peak, voltage across the resistor RL, over RL, which is equal VL peak. We found VL peak is equal 20.51 volts, and I have 20.51 volts divided by RL, which is equal 680 ohms, and this is equal 30.16 milliamps. This is my IL peak, the current peak which goes through this resistor. Next, I have to find IL average. Again, I'm going to use Ohm's law. IL average, which is also called IL DC, is equal VL average over RL. We found VL average. VL average is equal 6.52 volts. That's why I'm going to write over here 6.52 volts over RL, which is equal 680 ohms, equals 9.58 milliamps. This is my IL average. Next, we're supposed to find F out. F out is going to be equal to F in. But someone is going to say, how did you get this? My answer is, you're supposed to draw the graph for the secondary voltage. And remember, secondary voltage is going to be the sine wave, which has peak value 21.21 volts. Remember, y-axis is going to represent voltage in volts. This is time. This is my V secondary. Next, I have to draw VL, voltage across the load, peak. Remember that the diode passes the current only in one direction. If you are going to look at this diagram, you have to remember that this is anode, and anode is the positive terminal of the diode, and cathode is the negative terminal of the diode. So if the positive half a cycle is coming through this diode, on the output you are going to see also positive half a cycle. Of course, diode is going to consume 0.7, that's why you are going to have on the output of the diode 20.51 volts. When negative half a cycle is going to come to the anode, anode is not going to pass the negative half a cycle. That's why you are going to have 0 on the output. Because negative going to the positive terminal, negative voltage going to the positive terminal of the diode is going to reverse bias this diode, and the diode is not going to conduct. When another positive half a cycle is going to go through the diode is going to be forward biased. That's why I'm going to have voltage at the output. The diode is conducting. When negative half a cycle goes through, the diode is reversed biased. That's why I have nothing on the output. Now, please notice that my one full cycle of my secondary voltage is from this point to this point. My full cycle of output voltage, VL, has exactly the same length. So it proves that my Fin is equal Fout, which is equal 60 Hertz, because period of the secondary voltage is equal to the period of the voltage across the load. That's why Fin is equal to Fout. And we're supposed to find PIV, peak inverse voltage, for half-wave rectifier is always equal to V voltage peak secondary. So this is equal V secondary peak. I'm supposed to write V secondary peak is equal 21.21 volts. And these are the solutions to this problem.